Okay, so in this lesson we're going to be talking about what's called the graph translation theorem. We're not going to be doing the activity that's in the book. You can look at the activity and do that on your own to get a visual of what's going on here, but sometimes I've seen that that can actually confuse students more. They have a difficult time seeing the connection for some reason, so I'm just going to jump right into talking about the graph translation theorem. So make sure you have this written down in your notes if you don't have these notes. The graph translation says this, that essentially if we have an equation, we talked in the previous video about parent functions. Like here we have a parent function for the absolute value. If we have the parent function, that's going to change under certain conditions depending on what we're sliding or how we're moving our new equation, or where we're moving our new graph to. So here's how we can come up with a new equation. We're going to replace x with x minus whatever h is, and we're going to replace y with y minus whatever k is. And this will all come together by the time we get through this lesson. So right now this isn't going to make much sense to you, but hopefully as we go through it, it will. Now we did not do the chapter in matrices, so this piece here where it's talking about translations is new to us. Anytime we talk about a translation, we're referring to a slide. A slide is where we slide a graph or slide a figure to the left or to the right or up or down. We call those slides, we call those translations. So we use this capital T to represent that we're talking about a translation, and the H and the K identify how it's being translated. H represents how it's being translated horizontally. K represents how it's being translated vertically. That's what I'm showing you over here. So you want to make sure that you understand that concept. It's a pretty simple concept, so let's look at this example. Here we have this graph, that's y equals absolute value of x, is being changed under the translation of negative 2, 4, meaning we're going to take that graph, we're going to move it to the left 2 units and up 4 units. We want to come up with an equation of a line that will do that. So the graph translation theorem tells us that we can replace x with x minus h. Well, h is a negative 2. So it's going to be, I'm going to replace in the absolute value x with x minus negative 2, which I'll write as x plus 2. And my graph translation theorem tells us to replace y with y minus k. K is a positive 4, so I'm just going to write it as y minus 4. We can simplify this to say that y equals the absolute value of x plus 2, and then the plus 4 would go on the outside the absolute value. So if I had one like this, t sub 3 minus, or 3 negative 5, that means we have a translation that's going to move our figure 3 units to the right and 5 units down. So why don't you guys take a second, see if you can to write what this new equation will be. So pause the video and hit play when you're ready to go. Okay, so you should have paused it, and let's look to see what you should have got as your answer. So again, my value for h is 3, so it's going to be, I'm going to replace x with x minus h, so x minus 3. I'm going to replace k with y minus whatever k is, which is negative 5. So it's going to be y minus negative 5, which is the same as y plus 5. Or you could simplify it to say that y equals the absolute value of x minus 3. The minus 5 is going to go outside the absolute value. Please don't try to combine these. We have to put that negative 5, the minus 5, outside of the absolute value. Or you could leave it in the form y plus 5 equals absolute value of x minus 3. Now from that we can apply this also to parabolas. That's what this parabola translation theorem does. Is because our parabola, our general form, or our parent function for a parabola is y equals ax squared. All other parabolas are based on that. So, using this graph translation theorem, I would take and replace y with y minus k. I'm going to replace x with x minus h. So there you go. There's your equation for a parabola. We call this, there's a certain form for this. Now we're going to go on this next page. There's going to be a lot of writing. Don't get overwhelmed by it. Basically what we're going to be doing on the next page is we're going to be learning how to graph a parabola. Now right now the only way we know of to graph a parabola is by setting up an xy table. But that can be time consuming because you have no idea. This is kind of a shotgun approach where you're just hoping that you hit the target. It's not very specific. because sometimes we're just stuck with picking these numbers like negative 1, 0, 1, and 2. And we're hoping that we get a graph of the whole parabola, but sometimes picking these, we only see part of our parabola, and we don't see the whole thing. And so we need to pick more points until we can get to the vertex and be able to get to the point where it reflects. So we're going to come up with a way that's going to be faster than this kind of general blinded approach. So if you don't have my notes, you might want to pause it at this point, so in that way you can write down all of this information and get it down in your notes, and then hit play when you're ready to get a visual of what's going on here. So let's talk about this. So first off, there's three things that we're going to find when we go to graph it that's going to make the graphing easier, and that's the first thing is going to be the vertex. The vertex is really, really important. And in fact, if you notice, y minus k equals a times x minus h squared is called the vertex form of an equation. Just like we had the slope formula, or the slope-intercept form for a linear equation, y equals mx plus b, we call it that because it's really easy just to look at the equation and figure out what the slope is. That's why we call this the vertex form of of a parabola, because it's real easy to look at this and see what the vertex is. The vertex is going to be the coordinate h, k. Whatever those numbers are, we put it in this coordinate as hk. That's your vertex. Once we know what our vertex is, we need to look for the line of symmetry, or the axis of symmetry. That's going to be the equation of the line x equals h. So if h was 2, the axis of symmetry would be at x equals 2. Remember, that means it's a vertical line going through the point where x equals 2. Now that line is not technically part of the parabola. It's an imaginary line that shows us where we're going to reflect our points. And then maximum or minimum, if a is positive, if a is greater than 0, it's going to point upwards. And so the y value is going to be the minimum value. It's going to be the lowest point on our graph. If a is less than 0, so if a is negative, and by a I'm referring to this part of our equation, if a is negative, that means that our graph is going to point downwards, in which case our vertex is, the y value for the vertex is going to be the maximum y value. So let's see how we do this. First off, again, we want to find the vertex. The vertex is the point hk. Now remember, this is in the form y minus k equals a times x minus h squared. So for this, to find my vertex is going to be the point. Now notice it's x minus h, but here it says x plus 3. The only thing that would change that minus into a plus is if it were a negative 3. And for k, it's y minus whatever k is. Here's k, so it's y minus 5, so that means k is 5. Now here's an easy way to remember what h and k are. Remember, we're looking for a vertex with an x value and a y value. So an easy way to remember it is you just go over here, you look to see whatever happens to the x. The opposite of that is your x value for your vertex. So here we have x plus 3. So the opposite of that would be a negative 3. So we look to the y to find our y value for our vertex. It's y minus 5, so the opposite of that is a positive 5. So it's an easy way to figure out what your vertex is. So let's graph that. Negative 3, positive 5 would be here. That means we have a line of symmetry going through our vertex, which is the line x equals negative 3. Now the whole point in finding the line of symmetry is it helps us figure out what specific points to pick to plug into our equation to figure out what y is. Instead of just picking a bunch of random points, now we can be specific. And we're going to come up with 2 points. Now we want to pick 2 points either to the right or to the left of that line of symmetry. We don't want to straddle the line of symmetry, and you'll see why here in a minute. So we want to pick just 2 points to the right of it or 2 points to the left. It doesn't matter. They're going to be equally difficult. So we're going to pick negative 2 and negative 1. Now I'm going to use my equation, but notice my equation, I have this minus 5 here. I don't want to forget about that. So what I'm going to do is I'm going to add 5 to both sides. So my equation that I'm using here is it's now y equals negative 2 times x plus 3 squared, and then we're going to add 5. So I'm going to put negative 2 in my equation. Negative 2 plus 3 is 1. 1 squared is 1. Multiply that times negative 2, I get negative 2. Negative 2 plus 5 is 3. Do that process again now with -1. -1 plus 3 is 2. 2 squared is 4. -2 times 4 is -8. -8 plus 5 is a -3. Now when I graph this, -2, +3 will be here. -1, -3 will be approximately here. And my last step is to use this line of symmetry. Remember, if it's symmetrical, that means that, for example, this point here, that's 1 unit from that line of symmetry. There's going to be another point that's going to be 1 unit to the left of that line of symmetry. This point down here is 2 units to the right of the line of symmetry. So I'm going to have another point over here, 2 units to the left of that line of symmetry. Oops. And now we just connect these and make it into a parabola. And there you have it. So that would be your parabola using our vertex or line of symmetry, and then coming up with a couple of points and then reflecting it. Why don't you guys try the same thing on this one? So why don't you pause the video and hit play when you're ready to check your answer. Okay, so first off, our vertex, we take the opposite of -2 as a +2. The opposite of +4 is a -4, so my vertex is at the point 2, -4. By the way, I know that this graph is going to open upward since it's a +3 that's in front of there. But now we have our line of symmetry is going to go right through where x equals 2. So I'm going to pick 2 points. This I'm going to use 0 and 1. And I'll write this as y equals 3 times x minus 2 in parentheses squared. I'm going to subtract 4 from both sides, so it's going to be -4. So now when I put 0 in here, 0 minus 2 is -2, squared is 4, times 3 is 12, minus 4 is 8. Put 1 in there. 1 minus 2 is -1. Square that, you get a +1. Times 3 is 3, and 3 minus 4 is -1. Go to graph it. 0, 8 is going to be off my grid. 6, 7, 8 we'll say is about there. 1, -1 would be here. But now we reflect these points. So this point way up here, that's going to be 2 units to the left of my line of symmetry. There's going to be another one, 2 units to the right of the line of symmetry. Down here, where it's 1 unit to the left, there's going to be another unit, or one unit to the right. Oops. So there would be your parabola. You get the general idea there. Okay, we're going to end with this last example. This one kind of ties it together. Here we're given this graph y equals 1/5 x squared. That's the one that's in blue. We want to come up with the equation for the line that's in green. Now it might seem difficult because, or at first, you might assume that it's going to be difficult because of chapter 3 when we found an equation of a line. There's a big process to it. This is actually a very simple process if you understand this concept of the graph translation theorem. So we know our vertex was originally at 0, 0. It's now at the point 4, -2. Remember, that means that there's a translation here of moving it 4 units to the right and 2 units down. So remember, my graph translation theorem says to replace x in my equation with x minus h. So it's going to be 1/5 x minus h, so x minus 4 in parentheses squared. My graph translation theorem also tells me that if we're translating a graph, to replace y with y minus whatever k is. So y minus -2 becomes y plus 2. And that's it. If you want to simplify it, you can to say y equals 1/5 times x minus 4 quantity squared. I would subtract 2 from both sides, so we could write it like that, but otherwise it's just fine to leave it in that form. So why don't you try that with this one? So why don't you pause the video and hit play when you're ready to check your answer. Okay, so for this one you see that your h and k are -3 and +1. So we're going to replace k with y minus 1, replace x with x minus -3, so it becomes x plus 3, parentheses squared. And that's how easy it is. So hopefully you have an understanding of this graph translation theorem, how it all works together, so you can do well in your assignments. So good luck.